As Sebastian said, my name is Fernando Honig. I work for a cloud consultancy based in the UK. We do consultancy in cloud and DevOps. We are partnering with the major cloud vendors, so AWS, Google Cloud, Alibaba Cloud, etc. Today, my intention is to go with you through the journey that we are experiencing with some of our clients and try to see how that relates with your situation. So we're going to talk a little bit about RTO, RPO, a few strategies, a few services that one of the vendors, in this case AWS, provides, and ideally you're going to end up this session with some, ideas on how to improve your disaster recovery and backup strategies. You can contact me on by email or LinkedIn. My Twitter handle is Fernando Honig altogether as well, so you can also contact me there. So the first thing is trying to understand the difference between RTO and RPO. It sounds quite similar, but the importance here is understanding one thing is time and the other thing is data, right? So RTO is what is the time that we think is going to be not a problem to recover our system. And RPO is how much data can we lose without affecting our system. Two different things. Again, RTO, we need to calculate how quickly we need to recover. So we have an issue and how much time is going to take us to be back online, to be serving customers or requests again. So we need to make sure that we have that number in mind before planning our strategy. And every plan comes with money. You know that, right? So we say an hour, we say 20 minutes. Well, it's not free, right? Either we need to have replication in place, the typical master-master replication. We need to have people ready to jump on. And when we say people, remember that humans are slow, right? Waking up 2 a.m. in the morning and trying to bring a system up in 15, 20 minutes, it's not going to work. You're never going to be able to recover a system in 15 minutes at 2 a.m. in the morning. So automation here is key. An RPO is trying to understand how many backups do we need to have in order to get the latest information or data in place. So you say, I want to have an RPO of 4 hours. Sure. How often are you doing backups? Well, once a day. Your RPO is never going to be 4 hours, right? So incremental backups, hourly backups, snapshots, that is what we're going to start exploring as part of this talk. So again, to be clear, RPO and RTO differences. Let's say the recovery time, is going to be in an hour. So my application can be unavailable up to 1 hour. But how much data can we support? You don't have to make backups every hour if you can replicate and build that data again using other systems, right? So for example, let's say you are running a log analytics startup, and you have your logs stored somewhere, and you're processing those logs in order to generate some value-added information. Logs are still there, your system is down, your database is down, and you need to recover from it. So what you're going to do is, you're going to recover from the last backup. That is going to have, I don't know, maybe happened 11 hours and 59 minutes ago. But you have the logs. You still have those logs ready to process again and be up to date. Yeah, it's going to take time, yes, but you're still going to be able to recover having a, in this case, 12 hours RPO. Clear? So, if we talk about availability concepts, high availability is trying to minimize downtime for your application, which means that you don't have to be online 24/7. If your customers are able to cope with a few minutes, sometimes even hours of downtime, don't invest too much. You don't need to. Companies like Facebook, GitLab, AWS, they go down. Why you cannot? Try to make your data safe. That's key. Why? Because you typically hold customer information. And try to get your applications and data back after a major disaster. How many here run a data center? I'm not saying that you host in a data center. You run a data center. So you have a data center. Okay. How often do you get completely down? Was the building burned at some point? Exactly. So what you need to do is you need to make sure that the minor things are not affecting you as a whole, right? You need to make sure that your small, large, and sometimes even colossal events are not affecting your applications and your customers. Gave a talk a few months ago around SLA and the magical 5 nines that everyone is looking to achieve. And sometimes it's not even possible because your vendors are not providing you that. So that is when I say make sure that you are complying with what your customers want. Your customers want your data to be safe and the service to be available up to a degree. In this case, let's explore these small events. So who did an instance restart the instance never came up? Every time you restart an instance, it comes back. How lucky you are. You always did a application deployment and it went well, right? Exactly. So these are minor things, but they could become large scale if you do application deployment everywhere. Right? All instances at the same time. Another thing that could happen is that you put all your eggs in the same basket. In this case, the analogy is for an availability zone. And we know that availability zones go down. Not necessarily all services, but maybe we are using a particular service, and that particular service goes down in a particular availability zone. For the ones who are not familiar with the availability zone terminology, that is a set of data centers on a cloud vendor, Google, Alibaba, AWS. Another thing that could happen is that the whole region goes down. So we have an alien attack and, well, you know, a region goes down. Or even less dramatic, you just did a Terraform destroy, and well, I was thinking that it was the development environment. Well, actually, it wasn't. My variable, like when I did like export equal, no, didn't work. So it could happen. The question is, how do we fix it? And more importantly, can we do it very quick? So think about these events that happened in the last, I don't know, 2, maybe up to 3 years. Do you remember when GitHub was down because of the S3 US East 1 S3 issue? And will you think, hold on, it's GitHub. Don't they have like backups and everything? Yeah, yes. They had a backup in the same region. Okay. Question is, how do we fix that? How we make sure that that doesn't happen again? Well, there is a function or feature in S3 that you can replicate exactly what you have in one region to another. It costs double, of course, because I'm having exactly the same thing in 2 regions. But I'm covering myself in case something like this happens. You know Brexit, right? In around, I don't know, 2 months ago or something like that, there was one person who put a petition to make people's vote or something like that. I'm not bothered at all about that. And it got about 5 million signatures, or 7 million at the end. But yes, at some point, there was so many people trying to sign this, and the system went down because the petition system was unavailable. Why? Not enough, I will say, infrastructure to cope with the demand. They didn't know that it was going to happen. But also they didn't plan accordingly to make sure that if you have to support 5,000 a second, 5,000 signatures a second, we can cope with that. No, they never imagined. And that is key. Think of what could happen if, right? Or data unavailable, yeah, failed backups. How often do you test your backups? Once every week. Raise your hands. No. Once every month. 1. Once every quarter. 2. Once a year? Never! Yes, that is not right. Okay, so are you wasting your money? You're storing things that you don't even know if it works. Stop wasting money. Do you remember GitLab and the database destruction by this young developer? You don't, right? Happened like 2 years or 3 years ago. Again, the guy just put the wrong variable and goodbye database. GitLab had a backup, but they were running backups every 6 hours. Ouch. What about the last 6 hours? Lost. That is what we need to think about. You know, that type of potential situations. Don't blame the developer. Just make sure you have the right insurances in place. Let's talk about that, the insurances. How can we plan a disaster and how can we recover from that? Machine images. This is not cloud. Remember that these machine images are coming from OVF with VMware, so it's not that new. Now is like with cloud we can do fancy things, but the concept is there. The good thing about that is we can snapshot to another region. We can copy from Europe to the US, from Asia to, I don't know, India, right? We can share it across accounts or projects, which means that we can have a hardened image approved by security or the IT team, but that can be shared across all your projects, and everyone is using the same base image. Anton, in my previous talk, was talking about user data, that we can add commands and scripts so our images can be created all the same way. We can patch, we can update the OS before putting in production that particular instance. We don't have to go and manually run Ansible, blah, 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 on every single machine. As soon as the instance is booting, you just get your system up to date. In terms of storage, well, again, we can replicate that snapshot from one region to another, right? We can enable versioning. With S3, or object storage, you can enable versioning. Even you can add something like MFA delete. So in order to delete something, you need to be double authenticated, right? Again, you can replicate that S3 bucket to another region. So how these machine and snapshots work? You create a snapshot from a default machine image provided by the vendor, Google, AWS, Alibaba Cloud, Azure. And then you register that, in this case, AMI, it's an Amazon one, and you can launch that AMI. You can copy to another region the same AMI. You can add user data and create a new version of that AMI, and it's yours. And it could be private or could be public. Make sure you don't put any credentials in the user data or in the instance itself. In terms of networking, you can enable health checks on your DNS. With AWS, we use Route 53, which means that you can move from one region to another based on the health check. So if the load balancer is giving you another code than 200, then you move your request from one region to another. If for some reason a region gets some network degradation, it's going to be more latency. So the customer experience is not going to be the best. You move from one region to another. With load balancing, you can have failover options, which means that you have a load balancer, you have 2 or 3 pools of instances, and you can move from one pool to another based on a failover situation. You can have health checks, and you have the 200, 400, 500 code, and you decide when is a good time to move. VPC is the concept of a virtual private network, in this case cloud, which means that you can extend your data center to the cloud using something like, in this case, direct connect. So you connect your data center with a cloud vendor, and you extend your data center footprint. So in this case, imagine that we have requests coming to our F5 big IP load balancer. We route everything to our data center, but it costs too much for just, I don't know, I'm going to put a US example, Prime Day or Black Friday event, right? It costs you too much to just invest for that 1 week. So you extend your data center using VPC and Direct Connect, and you start routing some traffic onto the cloud, and you use something like auto-scaling for just that period of time. With databases, we have RDS, which is the managed service for databases. Snapshot data. Remember that particularly with AWS, what you can do is you can have automated backups, and those you can use it. It's an automated way of backing up to 14 days. Every single day, you define when. But also you can do manual snapshots, which means that, let's say you're doing a deployment. You're changing your schema. You don't want to wait for midnight to back up. So you back up before changing the schema. You do a deployment. Don't do it on a Friday. Do it on a Wednesday, potentially. And there you go. You have a manual snapshot of your old schema, and then you can have another manual snapshot of the new schema. And if you need to roll back, you need to go back and forth, you can do it. You can create another instance based on that snapshot. Combine read replicas with multi-availability zone. So you can have another read replica to just hold the reads, and you spread the load of your database. But at some point, that read replica could become your master. You just promote that read replica onto a master, and that's it. You have resiliency there. With the infrastructure, treat your infrastructure as code, which means that use templates. If you have to build dev 1, dev 2, dev 3, use exactly the same template, just change variables. Make tags of your code, of your infrastructure. So with application code 6.8, we're using infrastructure code 1.6, right? So then you know exactly when something fails, what went wrong, or what can we improve on the next release. During the backup phase, take backups. Yes, you're doing it. You can store backups in a very low cost system, like S3. And if you're not using it, you can also move it onto Glacier, which is the very, very low and cheapest object store on AWS. But this is really important. You need to understand, and you need to know and document what AMI you use. How to restore systems from backups. How to switch to a new system if a region is down if an availability zone is down. How to configure your deployment, because maybe endpoints are not going to be the same. Machine IPs might not be the same. So you can use, for files, NFS, SMB. For volumes, eSCSI, tapes, the same, and both you store onto S3, and based on a lifecycle rule that you define, you move it on to Glacier. For example, in this case, a hybrid backup kind of a strategy, you have a service in AWS called AWS Backup. With what you do is you define how you want to interact with your own data center or on-prem. So in the cloud, you use something like EFS, which is NFS v4. It's an elastic file system that you can put it on multiple instances at the same time. RDS, EBS, or even DynamoDB to back up automatically your workloads. On your office, colocation, or data center, you can have something called storage gateway, which is basically a VM that you connect in your VMware, and basically it backs up onto AWS automatically. Talking about restore, you retrieve backups from object storage. You bring up the required infrastructure. In this case, again, using something like CloudFormation, Deployment Manager, Resource Manager, or Terraform. You know exactly which is the AMI ID that you need to use, and because that particular AMI is in the right region and shared with the right account, and you know exactly how the load balancer has to be configured and the health checks for the load balancer, and you have everything automated, and you treat your infrastructure as code, it's not going to be a very high RTO. You restore system from backup, and you make sure you switch over to the new system by adjusting your DNS records. A bit of a strategies around recovery. So we have something like a pilot light, which means we will have our running system. In this case, we have Amazon Route 53. And we're pointing to, in this case, our web server, which is connected to my application server and to my database. The only thing in this case that we run, like 24/7, is my secondary database, which is a replica. Right? It's a read replica from my master database. I don't have any servers running on my disaster recovery region. But when we have a problem, we go and we start these servers, and we point my DNS onto the new system. Yes, it will take time. Yes, I will have downtime. But I can tell you it's going to be less than if you have to recover this. It's very cost effective, yes, because we don't have to run 24/7. The only thing that we need to do is we need to make sure that our AMIs are synced with the other region. We need to ensure that we have all the software packages that we need when the instance boots, and try to do it at least once a month. Not necessarily pointing the production DNS, but at least do a prod2.mydomain.com and see if it works. So in case of a disaster, we just bring up resources around the replicated core dataset. We scale the systems as needed to handle the current production traffic. Yes, it's going to be a degradation of service, but at least we're not going to be down for hours, if not days. The fully working low-capacity standby system is quite similar, but in this case, we are running this 24/7 on a small scale. You might say, okay, in order to save money, rather than having these auto-scaling groups running, I just put on 0, and whenever I have an issue, I just run some script that modifies my auto-scaling group configuration. I just have 1. Yes, it's going to take a little bit of time, but it's going to be quite automated. In this case, what we do is exactly the same. When we have a problem here, we just reroute to my new zone, and we start adding more capacity as we think is needed. It's going to be automated due to auto-scaling groups and some monitoring that we have in place. Advantages: we can take some production traffic at any time, which means that we could potentially run canary releases on my secondary zone. I can just reroute a small portion of traffic onto my DR zone or region. It helps me save some money because I don't have to run a full capacity. I just run a small portion of my infrastructure. In terms of preparation, quite similar to Pilot Lite. And the good thing is that I can continuously test this model. I don't have to run or put backups to work every month or every year. In case of a disaster, it immediately fails over because I have a health check in my DNS record. It should auto-scale to take all the production load. And in terms of RTO and RPO, well, it's going to take some time to just get the full production load. The other option is just the typical master-master, which in this case won't be master-master because I have a read replica, or in this case, like a standby secondary database. So make sure that when you do something like this, you still need to come back from this other region to the master DB, and that could be costly depending on the vendor. But yeah, in this case, the advantages is that you can switch at any time, no matter which one is down. You can scale both simultaneously, so you can say, okay, I'm going to put 5 servers here, 5 servers there, and you don't need to run kind of 10 servers in one place. In case of a disaster, yes, 5 servers here are going to be out of service, but then you're going to have 10 in the other one. So, in trying to recap a little bit about recovery strategies, we have costly here with multi-site active-active, and then we go to the left, yes, to the left, to a very low cost, but more kind of time in order to get this up and running, right? So backup and restore, yes, you only gonna spend money putting your snapshots in place, but that's it. Pilot Lite, you're still gonna need something running on the other side, and then we go up to fully working low capacity and multi-site active-active. Let's think about some sort of a scenario here. So we have Bob. So Bob is in charge of defining the best disaster recovery strategy for a hybrid architecture, and he did the setup based on the following requirements. So he's been told we need to have an RTO of 60 minutes. Our backups are stored in the cloud, good, and are taken daily. RPO has to be less than 8 hours, and we need to be able to build a new environment quick. And our application runs in the cloud, but our database is still in our local data center. So, RTO 1 hour, RPO 8 hours. Can be achieved? Who says yes? Raise your hands. Who says no? Raise your hands. Well, we have something. RTO and RPO, there is no certainty they can achieve 1 hour RTO and 8 hours RPO. Why? Well, because the database, the backups run daily, so RPO cannot be 8 hours. Right? Do you know how much time will it take to build a new database and import the data from your data center? How much it will take you to copy from the cloud to your on-prem database? Is your application code full of variables to cope with a change of endpoints? Is your infrastructure treated as code? Can you deploy a new environment within tens of minutes? Who says yes? Who can deploy a new fully production environment here in less than 1 hour? That is the question you need to start making yourself. So let's put a bit of tips here. Start simple. You don't have to build an environment in less than an hour. Start with less than a day. Next quarter, less than 4 hours. Next quarter, less than an hour. This is really important. Check for software licensing issues. Maybe you cannot run 2 environments at the same time. It really depends on what software you're running in your images, in your instances. Practice game day, and that is something that companies don't like. They don't like to spend time in game days, and when I say game days, it's not playing Minecraft or Fortnite. I'm saying trying to see how you can recover from a disaster. Have you heard about Chaos Monkey? Have you heard about Kong Monkey or Kong Chaos or something like that? So Chaos Monkey is something that starts removing instances or shutting down instances from your infrastructure randomly. And with that, you identify, oh, okay, so if that server goes down, everything goes down. Oh, we need to fix that. You start discovering these sort of issues. One routing table goes down or deleted. Everything is down. Okay, we need to fix that somehow. So you start making your infrastructure more resilient and able to cope with weird things that could happen in your cloud vendor. Don't blame your vendor, blame yourself for not planning accordingly. When you do this kind of chaos engineering, make sure that the system is failing the way that you expect. If not, make sure you do something to avoid that next time. How quick you fix it. Doesn't matter if it was 8 hours. At least you know how long it will take on a real case scenario. Who's monitoring 100% of your infrastructure here? Not many. And make sure you monitor everything. Make sure that you identify from a 500 error, 400 error to a 200 again. How long did it take? It's not, I run Terraform, system is up. No, it's not. Make sure the entire team knows how to recover from a disaster. You need to reduce your mean time to recover. You need to make sure that if Bob is on holidays, you don't call him because something is down. Follow up on incidents to uncover root causes. What happened? How did it happen? What's the root cause? And how can we prevent it? When I was managing a technical team before, for every single P1 we had, I said, I want to know root cause, and I want to have at least one item in the backlog to fix it. Then we can prioritize it. Yes, that's another issue. But at least we know what went wrong and how can we fix it next time. Start calibrating your alerting tools. I hate when I receive 10 messages because something is not really down. It's something like, it could go down, but I still have 10,000 messages. Right? So try to automate those alerts to potentially fix itself. So self-healing is like something that we all gonna have at some point. But we need to make sure that we are going in that direction. Create runbooks. Make sure that whenever you do a deployment, you have the checks. How many of you are using something like Jenkins to deploy and you love the green ticks, right? So this test passed, tick. This test passed, tick. Well, make sure that you have a runbook for when you deploy your infrastructure and your code, and you say, okay, this is good, this is good, this is how we do it. Don't take shortcuts. I know for a friend that they have two guys sitting on a room, and whenever they have a monitoring system on TV, and whenever something is red, they just go and restart the instance. It goes back green. Amazing. 8 hours doing that. And I say, hey, can we just tell your boss to, I can do it for free. I just go and I don't mind, but pour these two guys. No. This is when I see a green board. That's it. Anytime it's a red one, restart, keep going. So fix the issue for good, right? If you don't know how to do it, or you need some help, my company can get up to 10% of your AWS bill in AWS credits. You have a code here. If not, I have some cards here anyway. Just let me know. So yes, that's it. I would love to have questions from you. I think we still have time. And if you guys love stickers, I have stickers, plenty of them. And also I have some t-shirts to give away. So thank you very much for coming.
So do you have any questions to Fernando?
Thank you. Do you have any special recommendations for the TTL values for DNS? So one of the steps of the recovery was changing DNS to the new active zone. Does Route 53 have anything special about it? Or if you have long DNS TTLs, you still have to wait for that, for the new region to become active or visible to the customers?
Well, the lower the TTL is, the better. But it always depends. I mean, I don't want to say, yes, put 60 seconds. And then you say, you put the TTL 60 seconds, and my servers are taking 2 minutes to come up. And, well, it depends, really. You're not going to change that often your load balancer, right? So you can have, like, global DNS records. And then, in particular with Google, you know, you don't have regions, or kind of the VPC is global thing. So your load balancers are global. With AWS in particular, you need to have one load balancer in each region. But again, for a region to go down, and this never happened on AWS, it has to be like a major, like, alien invasion event, right? So having multiple load balancers in multiple zones, if a load balancer goes down, for instance, is more than enough. Thanks.
Any further questions? No? Then thank you, Fernando.
Thank you very much. Enjoy your lunch.